So let us start with the numbering of bytes, how TCP does it. The bytes of data being transferred in each connection are numbered by TCP. The numbering starts with a randomly generated non-zero number. The bytes of data being transferred in each connection are numbered by TCP. The numbering starts with a randomly generated number. We discussed about it, that why the numbering is needed. When we are transmitting data from a place of say Kolkata to a place say California, and I want all the data bytes to be transmitted and to be received, I need to number them, and I need to be doubly sure that all the data have been received by the receiver. Let us take an example to explain this further. Imagine a TCP connection is transferring a file of 6000 bytes. The first byte is numbered 10,010. Just now we discussed it's a randomly generated non-zero number. Now the query is, what are the sequence numbers for each segment if data is sent in 5 segments, and what are the criterias, with the first 4 segments carrying 1000 bytes each and the last segment carrying 2000 bytes. So my total data to be transferred is 6000 bytes. First byte has been numbered with sequence 10,010. I want the sequence numbers of all the segments. There has to be 5 with first 4 segments carrying 1000 bytes each and last segment carrying 2000 bytes. And your solution is here. First segment, my sequence number was generated and given in the problem statement 10,010. What was the size of that? I am embedding 1000 bytes of data in that segment. So my next segment sequence number becomes 11,010. How come? First segment had data bytes numbered from 10,010 to 11,009. Segment 2 sequence number 11,010. How many bytes? Again 1000. So my segment 3 sequence number is 12,010 because I had 1000 bytes here. How much data to be packed in? Again 1000 bytes. Segment 4 sequence number is 13,010. How much data packed in? Again 1000 bytes. Segment 5 sequence number is 14,010. How much data packed in? Now 2000 bytes. If we change the problem statement by a bit, say my 4th segment to have 2000 bytes and my 5th segment is back to having 1000 bytes, what would have been the changes? Segment 4 sequence number would have remained same, 13,010, but it would continued up to 15,009 here, because segment 4 now I am saying is a 2000 byte segment. 15,009 being the ending number here, my 5th segment sequence number would have been 15,010 and it would have continued up to 16,009 because the total data size would have been 6000 bytes only. I hope this is clear. Let us move to the next note. The value of the sequence number filled in a segment defines the number of the first data byte contained in that segment, and we have explained it in this example right away. The value of the sequence number filled in a segment defines the number of the first data byte contained in that segment. Next, another important note to proceed further. The value of the acknowledgement field in a segment defines the number of the next byte a party expects to receive. The acknowledgement number is cumulative. The value of the acknowledgement field in a segment defines the number of the next byte a party expects to receive. For example, if we go back here, this segment, once it has been received by the receiver, receiver will give an acknowledgement 12,010, meaning I have received till 12,009 I have received everything properly. Now I am expecting next segment to come with the first byte numbered as 12,010. That is the meaning of this note. Acknowledgement number is cumulative. We will understand this with examples in subsequent slides. Now, let us move to the first important property of TCP known as flow control. How does TCP implement flow control? A sliding window is used to make transmission more efficient as well as to control the flow of data so that the destination does not become overwhelmed with data. TCP's sliding windows are byte oriented. Say, let me try to take an example to explain this. Say, I am a bit hungry and I need a snacks break now, but I am having space in my tummy only for a single sandwich. Now, আচ্ছা এই জায়গাটার জন্য ঠিক আছে ওকে সো now let us proceed to the first important property of TCP known as flow control. How does TCP implement flow control? We will explain with examples. A sliding window is used to make transmission more efficient as well as to control the flow of data so that the destination does not become overwhelmed with data. TCP's sliding windows are byte oriented. Before going into example, let me take a day-to-day life scenario. Say I am a bit hungry, hungry for snack break. Now I am in a condition or in a position to have a single sandwich, a 2-slice sandwich. You being my student, you will always like me to have more. So you come up with a plate of sandwiches where there are 8 slices of those. Will I be in a position to have all 8? No. My tummy has space only for 2 slices of sandwich. You come up with 8 slices of sandwich. I will only take 2 slices. I will reject the other 8. Now, what actually you did? You being the sender, you overwhelmed the receiver with more amount of data. What was the end result? Receiver was able to take only that much data for which it has space. Rest of the data was dropped or rejected. Is not it so? Now, if that happens in our day-to-day life, now let us go into my TCP's flow control property. This is my sender TCP buffer. We are showing it as a straight buffer here, straight queue. And if you recall, we discussed there are 3 types of cells shown in the buffer. What are those? Blank cells which are ready to accept data from sending process. Pink ones are showing these are the data which can be sent immediately. Yellow ones are my bytes which are sent but not acknowledged. They need to be acknowledged, otherwise I have to resend them if I don't get the acknowledgement within due time. Receiver window, I have 2 types of cells shown in color coded form, the blank ones and the occupied ones. Now let us do a very simple calculation. My tummy was having space for 2 slices of sandwich. This receiving buffer or receiver window How many empty cells are there? Let us count. 1, 2, 3, 4, 5, 6, 7. There are 7 cells which can accept data. Whereas, how many cells are filled up with data? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 of them have been sent and acknowledged. Total number becomes 12. So, my sender window possibly could have been 12, whereas my receiver can only consume data in current situation of 7 cells worth. If I consider them 1 cell 1 byte, only 7 bytes worth. So now what happens? What becomes my sender window size? Let us understand it very clearly. As far as flow control is concerned, TCP's sender window is equal to the receiver window size. What was my receiver window size? We had counted, it is 7. See here, sender window size becomes equal to the receiver window size. 1, 2, 3, 4, 5, 6, 7 only. And my next byte to be sent as per the numbering is concerned, in this example it is 203. I hope you have noticed that your already sent but not acknowledged bytes must be your part of your sender window. Why? If you do not get the acknowledgement within time period, we will discuss it in error control. If you do not get it within the timeout period, then you have to retransmit them. Where from do you retransmit? You retransmit from the sender window only. Okay. So now what happens? This is not a static window. Why so? Because these data bytes will keep on getting acknowledged. These 200, 201, 202, the acknowledgements come. What happens? I will flush these areas, I will flush these buffer spaces and make them empty. They will become ready to get more data from the sending process. See here, this was my initial window. Now for example, I have received acknowledgement for these 3. What has happened? These 3 have been now made empty. I have sent these 2 chunks, these 2 data bytes, they have been marked yellow. Why? Now they have been sent but not acknowledged. So this was before I received my acknowledgement for these 3. This is after I received the acknowledgement for these 3 and after I sent these 2. Still now the size has remained 7. What did we understand? My window has actually slid towards left. We have shown it as a straight buffer, but it's, if we consider it as a circular buffer, I hope you understand it is a revolving structure. So it has actually slid in this diagram in the left side. Can the sender window get expanded? Why not? If the receiver starts consuming data faster, automatically receiver window size becomes bigger. I become more hungry and my tummy has space for say 6 slices of sandwich. I will welcome 6 from your 8. I will have to reject 2. So here, if my receiver starts consuming data faster, receiver window size being expanded, automatically my sender window size is equal to receiver window size. My sender window size expanded. Initially it was 7, now it is shown 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is my receiver window size has become. It will become my sender window size 10. Can it shrink? If it can expand by faster consumption of data by receiver TCP, why can't it shrink also? It can shrink. My receiving TCP starts consuming data even slower, automatically my receiver window size gets shrinked and eventually my sender window size gets shrinked. Now the reason for shrinking may not be because slower consumption only. It can be congestion. It can be congestion in the network. It can be congestion at the node. It can be so many other reasons. But whatever may be the reason, my receiver window can get shrinked, eventually shrinking my sender window size. It was 7 initially. This picture shows it has come down to 6. Absolutely fine. It can also happen. In TCP, the sender window size is controlled by the receiver window value as far as flow control is concerned. However, the actual window size can be smaller if there is congestion in the network. We will talk about congestion control in later part of this lecture, but as of now we have understood, as far as flow control is concerned, my sender window is equal to receiver window value. Okay. Some other points: the source does not have to send a full window's worth of data. We have seen it in the example. Only 2 bytes of data were sent, where actually there were 4 bytes of data which could have been sent. So it is not mandatory to send the full, it is not mandatory to send the full window's worth of data. The size of the window can be increased or decreased by the destination. We discussed about it. The destination can send an acknowledgement at any point in time. We will discuss it. Third point we will discuss in more detail in our subsequent slides.